Welcome to Group 9's video presentation of the ENSC 3001 project. This project concerns level luffing cranes which are used in freight transit terminals due to the horizontal translation of the coupler tip being a very efficient method for moving cargo. This is due to a lack of unnecessary lifting then lowering of cargo when only horizontal translation is required. The level luffing crane can be represented as a 4-bar linkage, and the aim of this project was to create a MATLAB function that produced coupler curves for all Revolute-based 4-bar linkages. In addition, a linkage was to be designed that replicated the horizontal movement of a level luffing crane coupler, and the group's code used to demonstrate the curve of this linkage. From the beginning of this project, there was a strong emphasis on effective time management, and numerous meetings were held to ensure group members had even amounts of work and interim goals were met. Minutes were recorded for each meeting. To design the dimensions for the linkage, an existing crane was examined and the relative dimensions and angles were recorded. These dimensions were trialled in several existing 4-bar linkage simulations, while the programming team were creating the linkage code from scratch. After some small adjustments, a crane design was settled upon that met the design specification. The first stage of code development was detection of the grass-off type of the mechanism. Nested if statements were used to determine and display the type that was input, with an error message displayed if an invalid linkage was entered. The motion limits of the configuration were then calculated to ensure the mechanism was modelled realistically and no complex numbers were generated. Theta 3 and Theta 4 were then calculated using the cosine and sine rules after splitting the mechanism into two separate triangles. Once Theta 3 was calculated via the atan2 function, the code then plotted the Cartesian coordinates of the coupler point. Here we can see testing of the final code on the right compared to the University of Illinois simulation on the left using multiple types of 4-bar linkage. It can be seen our code correctly modelled all of these linkage types. However, there are still some limitations to this code. It cannot automatically switch between assembly modes and is devoid of animation, which can be helpful to demonstrate how mechanisms function. Additional code was added to restrict the motion to that part with horizontal movement, that is, with the absolute value of the gradient of the coupler curve less than 0.01. The final mechanism design can be seen here along with the required dimensions. Testing of this design via our code is shown on the right compared to two online simulations on the left. With the member lengths, assembly type and relevant angles entered into the MATLAB code, the resulting coupler curve can be seen in red. A significant portion of the movement is horizontal or parallel to the ground plane, fulfilling the main requirement of this project. However, it is not perfect, partly due to a lack of joint offset, which can be seen on the photo of the left and in almost all horsehead level luffing cranes. Our code can only have a straight line coupler, no offset is possible. There was also diminishing returns in the time spent adjusting the dimensions compared to any reduction in vertical coupler motion. In conclusion, this project was beneficial in giving group members experience in how engineering problems are approached and solved in the industry. The major issue encountered was the incorrect formulae provided in their course reader, leading to significant time lost trying to debug code that was actually sound. The process of working with group members via constant communication, regular meetings, and setting interim goals maintained productivity and set a positive precedent for future projects. Thank you.